So hi all, yesterday we discussed about data, DBMS and database. So as I told yesterday, database is a collection of related data items, So if I tell company as a database, as you see, we have a number of companies in all over world, right? So purification is identification of company, right? So company with database. So company as a database with employees entity, then I have employees entity, then I have departments, right? Departments is an entity for database company. Then I have projects. So employees SSN. Name, age, department number is working for. So department has D number, D name, manager, SSN. Okay. Then I have P number, P name, P location, and D number. So this is a collection of related data items that you are doing. People are doing for database company with entities as employee, department, project, with employees attributes like SSN, department has D number, P project has P number, right? So department number refers to D number of department number, which is called foreign key. So primary key is which uniquely identify the entity set. Foreign key, which the attribute of R1 means relation 1, entity of employee refers to the department D number is called a foreign key, which reference primary key of other table is called foreign key. Here, so D number refers this one. D number refers department D number. So it has a simple database, collection of related data items. So company database, employee, department, project. So employees, D number is a foreign key, SSN is a primary key, department is D number, and manager SSN is a foreign key which refers SSN of a employee table, right? So project has P number and department has a D number which refers department D number and P number as a primary key. This is called a collection of related data items for database, right? This is the wonderful things that we done. This is the wonderful thing that we done in a last class, right? So now what I want to do is think about how the DBMS syllabus have been there. DBMS is a software to access and process a database. Accessing a database of company database and process like insertion, deletion, updation, providing security, right? That's what we done in last class for DBMS. So here, so what we done? So first is course objectives that I have. So what are the course objective that contain for DBMS 18CS 53. So what are the course objectives? First one, it make you to understand DBMS concepts. It make you to understand DBMS concepts. You can understand DBMS concepts. What is DBMS? What are the architecture? What are the different languages of DBMS? What are the advantages of DBMS? Everything you can discuss. You can learn the concepts of DBMS, right? You can the concepts of DBMS. Then SQL programming. So it's make you to learn SQL programming. Then you can think of concurrency control. Then you think of concurrency control and concurrency control and transaction management. Transaction management and transaction management. So 3. So this understanding concepts, then SQL programming, because SQL, without SQL programming cannot do anything, right? Entire DBMS is dependent on SQL. So SQL programming, then concurrency control. For example, imagine you have a railway. So we have seen railway websites, one of the beautiful and challenging and dynamic database, right? So it has to be, for example, see how many people are gone booking for a railway, right? How many people go for cancellation? How many people are waiting for seats? What about Tatkal, right? So you want to manage entire system, you want to manage trains, where is the train is going on, you want to track the train, you want to track employees, you want to track customers, you want to track customers, nothing but passengers, you want to maintain entire things, right? So where is, that is concurrency control. You want to manage the entire system, that what concurrency. This must not be duplicated, this must not be server loaded. So there must not be error, right? So you want to maintain that concurrency based on transactions, Make sure that you are handling population of India in a railway, because railway is the biggest traveling. We have a biggest areas and biggest population. So manage your required concurrency where all the people are. So for example, consider I want to book a ticket from Mysore to Tirupati, right? On a particular date. How many people are trying to book on a particular date? So it is possible to handle such a things as, so myself, first I will enter. I will try to enter. So Rane will get a chance to enter my details to book a ticket. Somebody saw on the pop about 30 people are waiting and backside to me that, okay, next me. So they want to maintain everything. So first passenger, next one. So like that, there is queue of system to maintain the concurrency, right? Based on transaction. And developing DBMS project. Developing DBMS project for real-time application. This is the objectives that specified for DBMS. So all this one learn and go for developing DBMS project. Developing a DBMS project for real-time application. Real-time application. Okay. So DBMS concepts to understand, SQL program to learn, then a concurrency to handle all the system, how to handle concurrency, how to handle the scheduling problems, how to arise deadlocks. Maybe deadlock arises. You want to eliminate deadlock. Then going for developing beautiful project for any real-time application. Right? So this is what the course objectives that define for a DBMS. So talk about course outcomes. So what all you can learn from DBMS. Can learn from DBMS. So course outcome, what I define is, so first thing you can understand DBMS concepts. As I told, understand DBMS concepts, understand DBM concepts. So when you learn this course, you are able to understand what is DBMS, what is database, right? What is schema, what is instance, what is database state, 3 schema architecture, advantages of DBMS, disadvantages of DBMS, classification of DBMS. You can learn all the basic concepts of relation model, so normalization, transaction management, the Java oriented courses, right? So everything can be understood by what you call as course outcome that we are defining. This is the first objective. You are able to understand the first course outcome is to understand the DBMS concepts. Then apply the SQL programming. Apply the SQL programming for a programs. So apply SQL programming for programs to analyze a database. Okay, to analyze a database. That's what we've done with the apply. Then analysis. So analyze the normalization, transaction management and a concurrency. Analyze the transaction management, concurrency, and normalization. You want to analyze such a concept so that the database can be without duplicated can be built. You need to understand, because you need to build a database which is there is no duplication, there is no repetitions, right? So only unique key must be exist. This can be done through analysis. Later part, develop. Later part, develop a database DBMS system for a real-time application. For a real-time application. So you want to develop a wonderful DBMS system for real-time application. This is what we are doing, right? So whatever the things is, whatever the subject starts with, study with, but later part you go with to learn, to develop a system, a DBMS system for a real-time application by utilizing a DBMS concepts, utilizing an DBMS concepts by using SQL programming, then you are analyzing normalization, concurrency, transaction management, utilizing all this triggers. We have assertions, we have a lot of things is going for develop a DBMS project for any real-time application like bank, hospital, company, various projects of entire real-time projects that we are doing, right? So the way is going on, such a way it's going on, right? Such a way it's going on. So you want to think of developing a real-time, see that employee entered the college, this is a real-time application, employee maintenance is a real-time application, library, one of the challenging tasks, because so many students have hire the books, right? Hire the books, return the books, they will lost the books. They want to maintain everything as books as authors, books as publishers. So thinking about library application is a huge task when you go for biggest universities, right? Biggest universities. If I go for developing university for library model for university, it's one of the challenging tasks, right? Because you want to maintain the book authors, who are the book authors, which department they belong to, who are the students, employees, non-teaching, teaching employees, right? So there is an employee database with a library model you need to attach, student model you need to attach, right? So student model has books you need to attach, so book lending. So this is task of challenging that contains. So one of the tasks with the library model has such a beautification, So here it has such a way that it has been developed. There is a course outcome of our DBMS, So I told course objective to understand, it provides to understand SQL programming, then your transaction management and concurrency, then developing a system. So same outcomes. So after analyzing these all objectives, you are studying all the syllabus, you come up with course objectives, course outcomes like understanding, apply, analysis, and a development of a project, development of a DBMS project, which includes with the lab part, That is what you call 18 CSL 58, where the lab experiments comes with what you call as mini project, with a mini project that you want to do for DBMS. So DBMS is such a way, it's most related to the lab practical. So without telling that, so lab practical is different than theory. No, nothing like that. Both are related. But when you go for SQL, if I teach in SQL, make sure that I'm teaching SQL with lab also, right? Because the SQL, what I teach here, it must be implemented in practical oriented, such a way that the system and syllabus have been developed, So here the model 1, defines, model 1 entire contains a huge task, a theory oriented, okay, with diagrammatic. So model 1 speaks about introduction to DBMS. So it has introduction, what is database, what is DBMS, advantages of DBMS, disadvantages of DBMS, files wise DBMS. So how the files was. So previously we were utilizing the files. So how file was. Now it has been database now. This file has a lot of drawbacks. There's no unique IDs. There's no unique IDs. There's a lot of duplication of data. But here we comes with a beautiful data types for DBMS. There's logical independence, there is a physical independence for DBMS. There is a conceptual design, there is a logical design, there is a physical design we talks about, there is a mapping we talks about. So everything is more advantage than files. So introduction you speaks about DBMS, advantage of DBMS, 3 schema architecture, schema you will learn. We learn schemas, we learn DBMS components, how it works, how it maintains the entire different types of users actually it maintains. Because users has different way users. When I do for a classes, I want to think about different types of users, right? If I develop a project for a particular company, so for any college, any university like CSE, Open University, I want to think about different types of users. Some knows computer, some does not know any programming. Some know only computers. Some want only blind customers. So I want to think about developing a DBMS components for different users. Different users. So how to develop, right? So there I want to think about the model 1, how to develop for different types of users. Advantages, classification of DBMS, single user, multi-user, with classification of DBMS with models, data models, hierarchical model, network model, relation model. So there was a OOC, object-oriented models for DBMS, right? So such a way the classification system goes on. Classification system is going on. Okay, so all this one study one in the introduction part. Then I want to think about this. After DBMS, this languages. DBMS comes with a language, that is DD languages. There is DDL, DML, DML, data definition language, which speaks about how to create a table, how to alter a table, right? So then you have DML, data manipulation language. So data manipulation language speaks about how to insert tuple for a created table. For created table I'm talking about. I'm not talking about anything. Created table, how to insert a tuple, delete a tuple, update a tuple. Then I want to think about, right? Then I want to think about how to maintain all this one. So DDL, DMS speaks about languages, how to create a structure of a database with the data types, with the relations that have been built in, with the constraints, that ruler following with a primary key and foreign key. So all this one comes with model 1 with introduction part with the languages, because as we speak with the Kannada language, it's a mother tongue. We have an English language to communicate, right? So here DBMS communicates with the DDL and DMS languages. So DBMS communicates with the DDL and a DML as a languages. So introduction, then we talks about entity relationship diagram. It talks about entity relationship diagram. So entity relationship diagram. So it speaks about how the database can be represented with the diagrammatic. So diagrammatic the way. Okay, diagrammatic way. So employee, if I consider employee as SSN. So employee as SSN with a department as a other table, other entity or other table, other table or a entity, okay? So employee works for department. So many employees works for one department. So many as fully participation, and only one department if I consider for entire college, then it is a fully participation. Right? So which date? So there is date, you can include an attribute for relationship itself. Okay? So this is the entity relationship diagram. There are two entities, that is department and employee. So the relationship between they want to develop, that is works for the diamond relationship that is going on. So employee works for department. So many employees work for one department. See how the representation goes. So DBMS as an employee table, there was department table, there was relationship I want to speak about. But here, diagrammatic way. So DBMS must go with a diagrammatic way. So employee as a SSN is a key. With the attribute. So works for, so employee myself working for information science department. So I'm giving information science department number, that is 4. So employee, many employees working for department relation. So relationship is built with a employee and a department. This is entity relationship diagram. So where you learn which is strong entity. So myself, employee. I have dependencies. My parents and my wife are depend on me, right? Me depends on my earning. So there are dependencies. So if we go for thinking about insurance were provided for me, so based on my dependents they provided. So I want to search my dependencies based on my insurance number, then the dependencies will depend on my SSN. Based on my SSN, you can search that how many dependencies I have for a particular insurance company, right? That time the employee is strong entity and the dependencies. So dependencies that has can become dependents which I have is called weak entity. So employee has one employee has many dependents. So if I talk about dependency, it's a weak entity. So indeed employee is strong entity, because strong entity is employee strong entity. My dependents, so it is nothing related to company. It is, you go for insurance, I can think of I have a dependencies which is identified by my SSN. It becomes weak entity because it depends on strong entity. It's become weak entity. Okay. So all this one studied in ER diagram. So the relationship, types of attributes that contains. Then I want to think about how the recursive relationship work, how the recursion work in a ER diagram. Based on this, how to develop a beautiful ER diagram with some constants, some rules. Everything can be studied in module 1. So introduction comes with a diagrammatic way. Module 2 speaks about SQL programming and relational algebra. That speaks about. Okay. So here if I talks about the programming, first I'll talk about relation. First you go with the what is relation model. So relation model speaks about tables. It speaks about the tables. It speaks about the tables that it contains. It speaks about the tables like this. It will be like this. So employee, SSN, name, D number. So SSN has 11, 22. It must be unique because SSN is a primary key. It's called primary key. It must be unique. So SS name and YY. Department number 1, 1, 2, working on. So department number is a foreign key which refers to department number. So it's a table. So relation model speaks about table. Table name is employee. Database is company. So it's employee is a table name containing attributes like SSN, name and a D number. So SSN is a primary key. It's a primary key for table called employee. SSN with IDs. So this is called tuples. So this is called attributes. This is called attributes. This is called relation name. This is called a relation name. This is called an relation name. Okay. So it is model 2. So relation name employee. So SSN name and department number is attributes. This is called tuples. Where data has been entered for particular table with the attributes. That is relational model. That is called an relational model that contains. So it has, as I told, it has programming. It has programming like this. For example, I want to retrieve the employees who is working for department number 2. Retrieve the name of the employees who working for department number 2. I want to write relational algebra and SQL. I want to write relation programming, relation algebra and SQL. Right? So here, see here. So first I will write, you told you want to retrieve the names of the employee working for department number 2. Consider this. Okay. So name with department number 2 with the department number 2. Okay, with the department number 2. From which table you are working for? Employee. With employee. So this is a table for this relation built it for. So when relation algebra talks only relation. So I want to retrieve the name of the employee working for department number 2. This projection symbol that defines what you want to retrieve. This is a condition that you want to provide. This is a sigma symbol that provides the condition what you are providing. That is department number 2. Which database? That is employee database. Employee database. You are searching for condition 2 who is working for department number 2 with the name of a particular employees you want to retrieve. For relation 1 will contain all the data of employees working for department number 2. department number 2. That's what I written in relation algebra. Relation algebra. If I write the same program in SQL, so select, what do you want to select? You need to select name. You need to select name from which table? From which table? That is from employee table. From employee table where the condition is department number 2. Where the condition is department number 2. Where the condition is department number 2. Where the condition speaks about department number 2. Okay. So this is select from where. The way of speaking this language is called SQL, one of the beautiful languages. It belongs to 5th generation of computers. So it is a fantastic thing that is done with SQL programming compared to C, C++, Java. It's a way of speaking the language. Way of speaking language is SQL. So select from where, set the name from employee where department number is 2. So relation is R1 with the name and department number 2 with the employee. See the relation between. So you are using symbols in relation algebra, but you are using keywords in SQL programming. So select from where. So then we have a group by, then we have having. So everything is there, right? It's a way of, just a way of simple programming that we done for relation model. Then we done for relation model with the SQL programming. So this is the table I given. So to see SSN name, department number, select from where. So this is the condition. I just have a question of written the employees, name of the employees who work for department number 2. We taken this table, let's select name from where employee, where department number 2, with the relational algebra applied. So I want to put a selection symbol with a condition symbol with a projection symbol. I want to retrieve database called employee. So this is want to learn with the model 2. Like this we do n number of programming for n number of databases. So we do n number of databases with a m number of programs we do for what I call as model 2 with speaks about only programming for SQL and a relation algebra. So next we have model 3 which speaks about advanced SQL. Which speaks about advanced SQL with some front-end tools. Advanced SQL means I want to create a view. I want to create a view. I want to create an assertion. I want to make a triggers. So what is views? Views is nothing but a part of the database you want to view. For example, I want to build employees working for only for IS department and working for a particular project called research. So that time I can create a temporary table where it contains the employees working for department number 2 with the research. That is view. View is just a temporary data where you can create the view as a table which cannot do modification for original database. You can do only for a temporary database what you created for views. If you want to insert working for only for research department of a views, you can only for insert for views. There is nothing effect for original database. That is done through views. Views. We have a number of views. You create a number of views for a temporary purpose of data. Okay. Then I can create assertion. Assertion is a rule. Assertion is a rule that we define. For example, so myself working in IS department, getting some salary. My salary cannot be greater than principal salary, right? Right. Because I am a professor working for a particular department, my salary cannot be greater than principal salary. How is it possible, right? A non-teaching staff cannot be salary greater than an employee's salary, who is teaching salary, or a principal salary. This is a rule that you are defining. There is a rule that defining that in a database that myself, an employee's salary cannot be greater than supervisor's salary. Employee's salary cannot be greater than supervisor's salary. Okay, supervisor's salary. That is the assertion you are learning about. Assertion you are learning about. Next one, triggers. Trigger means what? You want to intimate certain condition arises. For example, there's rule I define. By mistake you enter that my salary is 30,000, but my principal is 25,000. Then you must trigger that you cannot enter the salary which is greater than principal salary, That is what we do with the assertion and a trigger. So rules that you want to define. What we have a rule of primary key and a foreign key, where primary key defined as this only contain unique identification. So foreign key contain you want to reference existing of or existing of a primary key of other table, right? It must be exist there only you can refer. But assertion and triggers, you can create your own rules. You can make a own rules for a particular database what you define for. So hospital, if you go to hospital, doctor's salary cannot be greater than, right, original senior doctors. Nurse salary cannot be greater than doctor's salary. This is a rule that we made. Salary is one of constraints that I'm talking about. Okay, we have n number of rules like that in database. You can define your own database with your own rules through assertion and triggers. Okay, then I have to learn about front-end tools. Then I can learn about front-end tools. Front-end tools are like Java. So you have Python, you have ASP.NET, you have a simple HTML programming, you have PHP, everything, all they give an introduction of how the front-end tool looks like, what are the front-end tools, what all you can study, what all you can utilize for developing a mini project using this front-end tool as a back-end server to develop application for real-world things. That is what you learn in Model 3. Then I go for Model 4. Which speaks about normalization. So then they speaks about first normal form, second normal form, third normal form, fourth normal form. Then they have n number of algorithms where I speaks about. What I speak about. So how to make it as a dependency. So what is dependency? How is the one attribute depend on 5 primary keys? How the dependency can be overlapped? What is the transaction dependency? So what is the function dependency? What is fully functional dependency? What is partial functional dependency? Everything is studied in Model 4 with a functional dependency programming. How the dependency can be done, how the duplication can be avoided by using dependencies. Everything can be studied in what you call in Module 4, that is contains complete syllabus of normalization. Complete syllabus of normalization with the first normal form, second normal form, third normal form, fourth normal form, fifth normal form. How this algorithms comes from this functional dependency algorithms can be done. Everything can be studied in what you call as model number 4. Model number 4 that we started. Then we comes with Model 5. Where in the Model 5 starts with a transaction management and a concurrency control. We comes with a transaction management with concurrency control. What we speaks about? We speaks about a lot of things here. We speaks about how the transaction works, how the state, start state, end state, what are the middle, what you want to do between start and end state. So how the transaction works. One transaction enters, how to avoid other transactions. So one transaction afterwards can work in parallelly. So T1 with a T2, right? So everything can be studied. How the scheduling can be done for T1 after T2. Scheduling, deadlocks can be worked. So how the deadlocks can be avoided. What the two-page locking. So how the locking system works. How we can lock up object. How can release the objects. Everything is studied in model number 5. Everything studied in model number 5. That is with a transaction and a concurrency control. So this is the beautification that we have for syllabus in DBMS. Fantastically done syllabus. Really appreciate because the syllabus goes such a wonderful flow. There is no overlap between the model 1 or a model 2. Everything flows from start with introduction, then diagrammatic. From diagrammatic I want to build tables. For tables we have a queries. Then there is a maybe you go for creating some constraints for tables. Then go with the normalization to remove the duplication, to check for dependencies, how the dependencies works. So how limited dependencies is required. Then go for beautification of table. Then I comes with working for transactions. So transaction we do, there may be scheduling, there may be transaction overlaps in a real-time application. Then I want to go solution for how to make a scheduling between this one and how to overcome a deadlocks. Then overall utilizing this, use the front-end tools for develop a database application. Everything we does in a DBMS beautification system. So this is a model 1, this is a model 2, this is model 3, model 4 and model 5 that defines. But which subject, which the book you want to refer? Which is the book you want to refer for to learn DBMS? First one is Nawate, one of the fantastic man who written various edition of the book. You can refer 6th edition of Nawate, okay? And there is a Raghuram Krishna. To refer for the model number 3. For model number 3, you want to refer Raghuram Krishna book, Fundamentals of DBMS System. You want to refer for model number 3. Model 1, 2, 3. Model number 1, 2, 3, you can refer for 1, 2, 3 in the half of the part, and model number 4, you want to refer Navate. Okay, you want to refer Navate. You want to refer Navate. You want to refer Navate and Raghuram Krishna for model number 3 and model number 5 with transaction and concurrency control. It works with the Raghuram Krishna well. And 1, 2, 3, 1, 2, 4, sorry, 1, 2, 4, that refers to, you can refer a book called Navate. So this is the course that this, and you can go for utilizing NPTEL. You can using NPTEL videos. This is a reference, and we provide the notes and the videos for you peoples. We provide notes and videos for you peoples, so where you can utilize to learn well. And this is one of the easiest subject and more core subject for information science and computer science engineering. So more core subject for both the streams. It's one of the fantastic subject. You want to learn it out. So many of our students, so many of senior students, they talks about, sir, what do you learn about, what do you teach about the SQL programming, still I'm utilizing my company. Let's make my credits, right? When students tell, I remember after going for 2 to 3 years of going to company and utilizing my what we taught in the class, it's one fantastic thing what we can do, right? Such a way we do the programming for SQL, or such a way we teach the DBMS. Really, I love this subject. I'm teaching almost 4 to 7 to 8 times, but still I'm going to learn this subject because of the subject is going in updation. As you see, because as you know, people, computer science or information science go on day by day, it is updated. Syllabus is updated. The programming is updated, right? Programs have been, nowadays we have a n number of tools with a fantastic toolboxes readily available, right? So to cope up with, you want to go on learning. You want to day by day, you want to learn, upgrade your database, and comes with a fantastic way of teaching for you people to learn. Right? So this is the fantastic thing of introduction to DBMS. So next class I will go with what is the syllabus comes with files-wise DBMS, advantage of DBMS. Model 1 we start with the theory part of things, then we comes with the ER diagrams, then we go with the SQL programming, then we go with the what I call as normalization, later part we go with front-end tools, last with the transaction and concurrency control. Okay, thank you so much. Hope you had enjoyed this class. It's fantastic, useful for you people. Thank you.